All right, so we're finally to the point where we can talk about how Parkinson's affects the basal ganglia, okay? And so in Parkinson's disease, right, that's PD, the major thing to understand, although it's not exactly understood why it's the case, but that the dopaminergic cells of the SNPC, the substantia nigra pars compacta, selectively die off. And so what this means is a reduction in dopamine throughout the entire system. So I won't tell you what effect that has before I walk you through what this is going to trigger. So let's look at what happens in the direct pathway first. A lack of dopamine means that there's less stimulation of D1 receptors of medium spiny neurons, right? Less stimulation of D1 containing medium spiny neurons. And what that means is if the D1 containing MSNs aren't stimulated as much, and remember the D1 pathway was an excitatory pathway. So this means that there's less excitation of these MSNs. Maybe we should write that in here. Well, with less excitation, their output is reduced. So they release less GABA. Well, what does that mean? That GABA, remember what it typically did was inhibit the output of the tonically active GPIS neurons, right? But that doesn't happen as much in this case. So there's reduced inhibition of the internal segment of the GPIS. Well, what does that mean? It means that there's more inhibitory activity coming from the GPIS, which is normally smoked out or put out, extinguished by the GABA, right? So this means that there's an increase in the GABAergic inhibition due to greater output of the GPIS, right, which is normally, right, if dopamine is present normally, not occurring. Well, this means that there's more inhibition of the VAVL. Which means there's less excitation, less excitation going to motor programs. To motor neurons, right? And so at least with respect to the direct pathway, degeneration of SNPC neurons, right, which reduce dopamine binding to D1 receptors, has this effect of inhibiting motor neuron activity, right, through this pathway. What about the indirect pathway? What is that going to do? Again, I think it's useful to map this out and see if we reach the same conclusion, right? In this case, degeneration of SNPC, right, eventually led to decreased motor neuron output, less movement. All right, let's follow what happens in the indirect pathway. Again, we start at the same place, right? That the SNPC neurons are degenerating. So they're releasing less dopamine. And what this means is that neurons, medium spiny neurons within the striatum, that contain D2 receptors are, well, are they going to be more active or less active? Well, they're going to be more active. Why? Because remember, D2 containing receptors, right, so neurons, medium spiny neurons that express D2 receptors get inhibited. So again, under normal circumstances, dopamine would bind these neurons that express D2 receptors, and they would reduce their output, right? But because these D2 receptors aren't having dopamine bound to them, they don't reduce their activity. Instead, they increase their activity. Right? So in this case, these D2 expressing MSNs release more GABA. Onto the globus pallidus, but onto the external segment. Right? And so I think this is a key place where people get thrown off. How is it that these medium spiny neurons change what they do? Well, if they contain D2 receptors, dopamine typically reduces their activity. So they don't release as much GABA onto the GPES. But in this case, these D2 containing receptors go unstimulated, so they're more active, so they release more GABA onto the GPES. Okay? Well, what does this mean? It means that the GPES keeps the subthalamic nucleus from, well, let me stop for a second. Let me back up. Let's look at the diagram before I go forward here. I want to take a pause for a second. So we have increased output of these D2 receptor containing MSNs, right? And so there's more GABA released onto these neurons of the GPES, okay? And so what this results in is greater tonic inhibition, right? So maybe I should note that here. Right, so as I have in number 3, D2 expressing medium spiny neurons release more GABA onto GPES, right? So this means there's more inhibition of GPES neurons, which means that they're less output of those same neurons. And remember, these neurons are producing GABA. So under normal circumstances, activity of these D2 containing medium spiny neurons reduces, well, I don't want to say that. What I will say, right, is that when we have degenerated these dopaminergic cells, the result is increased activity of these D2 receptors such that more GABA onto the GPES reduces what they can put out. All right, so that would be step 5. Maybe I'll put this, less GABAergic output of the GPES. Right, and that's why this arrow is shown with a narrower diameter here, right? So now there's reduced inhibition of the subthalamic nucleus. So what does that mean? Well, now, when the cortex stimulates it, there's very little inhibition here, right? So the subthalamic nucleus can produce a bunch of excitatory output. So the subthalamic nucleus produces increased glutamatergic, right? That is positive output. Right? What this does is it stimulates the cells of the GPIS, right? And because they're being stimulated, they put more, or they have a greater output. And what do they release? GABA. Right? So the result here is that GABA inhibits VAVL. And the result is, again, decreased excitation, a reduction in the likelihood of movement. Okay? So even though D1 and D2 receptors mediate different effects, D1 receptors, when dopamine binds, show an excitatory response. D2 receptors show an inhibitory response when dopamine is present. Okay, so cells that express D2 receptors with dopamine decrease their activity. Without dopamine, as we see in this circuit, those D2 receptor-containing neurons with no dopamine increase their output. It's another type of disinhibition. Okay, but the net result of degeneration of these dopaminergic neurons in the SNPC in both pathways, right? They unite, both pathways unite such that we see what are called hypokinetic movements. And I'll pick it up there when we do the next video.